Hi! In this last video on linear equations, we're going to learn about literal equations. And what are literal equations? So a literal equation is an equation involving at least two letters or two unknowns. Okay, this is very common in engineering subjects because majority of the formulas or the principles that we use to solve particular problems will always contain at minimum two specific parameters. Sometimes it could go more than four parameters in a single formula, and it's very important for us to understand how we are going to solve for one of the many unknowns that you have in your equations. Okay, so solving for a particular variable of a literal equation is separating the unknown on one side and the rest of the letters on the other side of the equation. Similar to what we've been doing with linear equations in one variable like x, we were able to solve x by keeping it at the left side of the equation and making sure it is alone at the left side of the equation and taking all other terms at the right side of the equation to be able to solve for the unknown. Similar with literal equations, your target or your goal or objective in this kinds of equation is that you'd be able to put the specific unknown we are solving for, to be alone on one side of the equation, and then the other letters, parameters, or variables that you have should be kept at the other side, okay, opposite to the one we are solving for. So let's illustrate how we use or how we solve literal equations with three examples. So let's get our notes. And let me write here literal equations. Okay, so we have number 1. We are given 2xy minus a all over b, which is equivalent to 2x minus b all over a. The first question is to be able to solve for x. Okay, so being able to solve for unknowns in literal equations always depend on your style of solving. As long as you're not doing anything illegal mathematically, then all is well in solving for the unknowns. So you have maybe two ways. Okay, you have two ways on how you'll be able to solve for x in the given equation. As you can see, x appears on both sides of the equation. So you have x here and you have another x here. And the catch here is that x, although it is not enclosed in the parentheses, okay, we cannot simply pull it out from the fraction, okay, because it is part of a numerator. So what you can do is, number 1, remove the fraction. Okay, or number 2, create partial fractions. Okay, so if ever you would want to remove the fraction, maybe by cross multiplication, di ba? That means you will have a multiplied to the numerator of the left side and b multiplied to the numerator of the right side. Or should we say, that's 2x minus a all over b, equivalent to 2x minus b all over a. We multiply both sides by a to cancel a at the right side of the equation. And at the same time, we multiply both sides by b to cancel b at the left side of the equation. Okay, in that way, you will have a multiplied to the whole numerator, which is 2xy minus a, equivalent to b multiplied to 2x minus b. In this case, x becomes enclosed by a parenthesis, so we have to remove the grouping symbols. That means we need to distribute. Same goes for the right side of the equation. And there you'll have 2axy, I just arranged alphabetically, minus a squared is equivalent to 2bx minus b squared. So since there are no more grouping symbols, there are no more terms multiplied to the whole members or the left and the right sides, we can now transpose all the terms that contain the unknown on the left side of the equation. So, ito yon, and move the remaining ones to the right side of the equation. So, I will have 2axy, okay, minus 2bx, and that would be equivalent to positive a squared. I wrote a squared first because it became positive, followed by negative b squared. Okay, so to be able to solve for x, since x is common on both terms in the left side, I can factor out x. And I'll have 2ay minus 2b. And that would be equivalent to a squared minus b squared. So solving for x, you have to divide both sides by, so kailangan matira si x dito, you have to divide it by 2ay minus 2b. And you do it this, and you also do it on the right side of the equation to make the given balanced. So we have x equivalent to a squared minus b squared all over 2ay minus 2b. And this is our answer for x. Okay. I mentioned earlier that we can solve this by creating partial fractions, right? What would happen if we did that? Okay, so what I'm going to do is from the given 2xy minus a all over b equivalent to 2x minus b all over a, since there are several terms in the numerator that shares the same denominator, I can separate them into small fractions or separate fractions. So I can write this as 2xy over b minus a over b equivalent to 2x over a minus b over a. And then in that sense, yeah, I can now move the terms that contain x. So I'll be moving fractions. So I have 2xy over b and 2x over a as the fractions with terms or with the unknown x. And then I'll move them on one side of the equation and move the other ones at the right side of the equation. That makes this positive when you move it to the right. So I write it first a plus b minus b over a. What I do next is factor again the common term that appears on the left side of the equation, and that is your unknown, which is x. So I'll factor out x, and that would be multiplied to 2y over b minus 2 over a equal to a over b minus b over a. And for me to be able to solve for x, I have to divide both sides by 2y over b minus 2 over a. I'll do it on the right side as well. And as you notice, this kind of solution is quite longer than the previous one we used. And the purpose of showing you this is to show you that your technique and your style in solving may be longer than others, but as long as the principles are followed or you did not do anything illegal in terms of math, then it's okay. Then your style is okay. You can do so with your approach. Pero when it comes to engineering practices, we should always strive to make our solution simpler, and that in that way we'll be able to save time and effort. So, anyways, I'll be able to cancel 2y over b minus 2 over a on the left side of the equation, and for me to be able to solve for x, what you have to do is take an LCD of both the numerator and the denominator of your mixed fraction. So to do that, I have AB as my LCD. So I have AB divided by B, that's A times A. So you have A squared minus AB divided by A times B, that's B squared. In the denominator, I will also have AB as an LCD. So AB divide B, that's A times 2. So we have 2AY minus AB divided by A, that's B times 2. So you have 2B. In that way, AB can be cancelled because they both appeared in the denominators. Okay, and we'll have x equivalent to a squared minus b squared all over 2ay minus 2b. And this answer is similar to our previous answer, which is this one. The only difference is that this one is obviously shorter in solution. Okay, let's try to solve for x this time. let's try to solve for letter B, which is looking for y. So, in letter B, we're being asked to solve for y. Again, I write the given. 2xy minus a over b is equivalent to 2x minus b all over a. So, as you can see, okay, y appears only on the left side of the equation. So, what I do is simplify or remove the fractions in the left side of the equation, and that is by multiplying both sides by b. In that case, this will be cancelled. I'll be left with 2xy minus a, which is equivalent to 2x minus b times b all over a. Okay, or you can write it as 2x minus b over a, the quantity multiplied to b. Either of the two, okay, is correct. Next, I have to transpose a to the right side of the equation so that I will only have 2xy on the left side. So, that would be 2xy is equivalent to 2x minus b times b all over a. The right side, okay, the right side to be added with a. Since I am solving for y, what I do next is divide both sides by 2x. So that would be y equivalent to the quantity of 2x minus b times b all over a plus a. The whole quantity on the right side will be divided by 2x. So what you can do is simplify the right side of the equation as you go along with your solution, or you can take this as is and simplify before giving your final answer. So what I can do is take the LCD in the numerator. I'll take an LCD for this, and that's obviously a. Okay, I'll be having 2x minus b times b plus, I will have a squared. That's a divide 1. A divide 1 times a. So we have a squared all over 2x. In that way, I can simplify that as 2x minus b times b plus a squared all over 2ax. You can expand this. You can expand this term. Depends on your need in your equation. But this is already considered correct. Okay. Let's go to the second example. So for the second example, we're given y is equivalent to 1/2 d multiplied by x minus ab over L. We are being asked to solve for a. And a appears to be inside the bracket or inside the parentheses. Okay, so what we can do here is, usually what I do is wherever the unknown is, I keep it in that side, and then all the other different variables or all the other terms different from the unknown, I move it on the opposite side. So it doesn't matter for me if it is on the left or on the right. Okay, what I do is just, after being able to solve for the unknown, I just switch places whenever the unknown happened to be on the right side. I just switch the equation. Okay, so what I'm going to do is be able to solve a at the right side of the equation. So I should be able to transfer all of this to the left side so that they get equated to just a. So the first thing to do is before I can free the unknown, before I can free this up, okay, since it is enclosed in a parenthesis and that parenthesis is still multiplied to this, I have to divide both sides by this fraction so that I will only have the group terms or my binomial at the right side. Okay, so I will have y equivalent to 1/2 d times x minus ab over L, and I'll have to multiply both sides by 2 over d or divide both sides by 1/2 d. What would happen here is that I will have 2y over d, okay, dividing fractions on the left side. And that would be equivalent to, this will be cancelled, x minus ab over L. Since my unknown is a part of a fraction, I'll move that fraction to the left side or interchange places with 2y over d since I'm solving for just a. So I'll have that as positive ab over L, equivalent to x, and this will move to the right side, so it will be negative 2y over d. To be able to solve for the unknown, which is a, you have to divide both sides, or maybe multiply both sides by L over B, or divide them by B over L. In that case, this is cancelled, and I'll be able to solve for A, which is equivalent to x minus 2y over D, okay, multiplied by L over B. So, dividing fractions. Okay, and I can take this as my answer. Okay. Next, if instead we are being asked to solve for L, so letter B, we're solving for L, and that is y equivalent to 1/2 d times x minus AB over L. So our target is to be able to solve for L. So I'll do the same process we previously did. That is, I'll divide first both sides by 1/2 d. So this will be cancelled on the right side. Okay, and I will have 2y all over d on the left, and that's equivalent to x minus AB over L. Next is move this again to the left, switch places with 2y over d. So I'll get positive AB over L, and that's equivalent to x minus 2y over d. Since I am solving for L, what I'm going to do is multiply both sides by L. Okay, this would be cancelled on the left side, and I will obtain the equation as AB equivalent to x minus 2y over d multiplied by L. This time, to be able to solve for L, okay, I have to divide both sides by x minus 2y over d. Okay, and this will be cancelled. In that way, I will have L equivalent to AB all over x minus 2y all over d, because this is L equivalent to this expression. Simplifying that, I'll be able to get L as ABD all over x minus 2y. And that's my answer in solving for L. Now, let's move to our third question, which is x equivalent to the square root of c all over d minus 2z. And first, we are being asked to solve for d. So for me to be able to solve for d is on the right side of the equation. So what I'll do is just move this to the left, and that will result to x plus 2z equivalent to the square root of c all over d. If I'm solving for d, I can just cross multiply this to the left side. So that would be d equivalent to the square root of c all over x plus 2z. And there I have it, the value or the equation for d. Moving on to our last question, which is letter B. In here, we're being asked to solve for c. Same equation, you have x equal to the square root of c all over d minus 2z. So what we do is move 2z first to the left, so that would be x plus 2z. You'll have square root of c, the fraction where c is in, at the right side of the equation. And then I'll multiply both sides by d, so I'll be having square root of c only on the left side. So that would be x plus 2z times d. And that would be equivalent to the square root of z. To be able to remove the radical, I'll have to square both sides of the equation, and that will result to d times x plus 2z. I just placed the monomial first, or the single variable d first, squared, equivalent to c. So this could be my answer, or if you want, you can further expand the left side. Okay, but if you will properly write that should be c equal to d times x plus 2z quantity squared. And there you have it, your literal equations.